Let me give you. Excuses. Here's my excuse. I have a good excuse, not really, it's an excuse. My excuse for why we went through 6.3 and 6.4 on Wednesday is I didn't look at the fucking syllabus and realize I had it set for different days. So what we're gonna do today is I realized that we went through it kind of fast. Let's redo some of these problems now that if you've hopefully taken a look at them. Let's build on your knowledge and let's just grind some more graphs of sine and cosine. So. I'm gonna call this 6.3 and 6.4b examples. We went over all the stupid rules and definitions and all that crap no one likes to write down. Let's just go straight to the basics. In fact, let's do the basic y equals sine x. In fact, I'm gonna throw up a little picture of my unit circle over here. With just the 90-degree angles written in. Remember, on the unit circle. Hopefully you guys have memorized this by now. If not, I'll find out pretty soon. We have a test coming up in a couple weeks. It's a radius of 1, so it's cosine theta and sine theta. Here cosine with the coordinate we can see right away is 1, 0. This is just standard graphing right here without throwing in any angles. And this corresponds to 0 and 2 pi. This corresponds to pi over 2. This corresponds to pi and 3 pi over 2. So from the unit circle, when we use y equals sine x, x is in the spot of our angle. So that's where our red values are going in. Our red values go in there. And y is pulling the y coordinate. Pulling the y coordinates. And I don't know that I made that, now we did a table of these, but I don't know that this is helpful as maybe looking at the unit circle. Since I've got you to hopefully memorize that, seeing how it correlates to that. We're literally just pulling crap from that. So if we graph this. This is easiest, I mean, we could do values at the 30, 45, and 60 if we wanted, but that's just filling in more dots. We're gonna go out 2 pi, and then I'm gonna not write in pi over 2 and 3 pi over 2, but we'll know that they're there. This is my y-axis, this is my x-axis. Maybe we'll go backwards. And x is our angle. So pulling in shit from there, we see at when x is 0 degrees, y is, or not degrees, radians, when x is 0 radians, y is 0. So we're right there. When x is pi over 2 radians, I guess I need a vertical component of 1 and -1. When x is pi over 2, our angle, y is 1. When x is pi, y is 0 again. When x is 3 pi over 2, we're at -1. And when x is 2 pi, we're back at 0. We could go around further, the next time around the lap, this would be 5 pi over 2. So if I had another dot in here for 5 pi over 2. We would be back at y equals 1. This is a graph that keeps repeating. And you draw a nice little curved thing, trying to make that these things are the top values and bottom values. When you hit the pi over 2 amounts, pi over 2 and 3 pi over 2, they're the top and the peaks and the troughs of a wave. Don't do what Keith does. I'm throwing Keith under the bus right now. Keith had a bad time of doing this. He'd do some shit like this, he'd get the first one, and then all of a sudden he'd be like this. And like totally miss the dot. I'm like, dude, aim for the dots. Aim for the dots. Sorry, Keith, but this was helpful. It's a learning exercise for everybody. Aim for the dots. We could go the other way too. What if we went backwards to this would be negative pi over 2? And we would have a value of -1. And if I went backwards a full radian or pi radians, we'd be at negative pi and we'd be back at 0. We can see this wave is an unending wave. It just keeps following they're called oscillations. And any sequence you look at that where it starts to repeat, I could go from here, which was negative pi. To here, which is pi, and I can see this is where we start going downhill from 0. Pi is where we start going downhill from 0. This is where the wave repeats. We can see there's a pi between over here, pi over here. The period is 2 pi. Any 2 points, we can find 2 points where this happens. We can go from pi over 2 to 5 pi over 2 and see that we go from the start of a peak to the start of another peak. Again, and another way of looking at it is doing subtraction. 5 pi over 2 minus pi over 2, my end value and my start value. I get 4 pi over 2, which is 2 pi. We can find that period from any 2 points as long as it starts repeating. The one we use consistently is 0 to 2 pi itself. Because why not start with 0 if you can? 0 is a nice simple number to work with, you add something to it, and you get the number that you're adding. It's a perfect number. What is?
Can't the period change, it be shorter or longer?
Yeah, that's when we put stuff inside the parentheses. We're getting there. I'm just making sure everyone like has this sign basis locked in.
Well, I mean, but if this, in this graph, would there be a question? For the period, where they define the period as longer than for the same graph? Or is the period always?
No, period is where it starts repeating.
That is-
So for the graph, for this same graph, it's gonna be 2 pi every single time.
That establishes that.
Yeah, it's where the pattern. That's a good way of looking at it, where the pattern is established to start repeating. And if we wanted to do y equals 1/2 sine x. Notice when we put our angles in here, our x values are angles. The sine values where these peaks and troughs occur is not changing. What is changing is we gotta take the resulting value. And take the results of sine. And multiply by 1/2. So all the zeros times 1/2 don't change. Where you notice the real difference is where you're at your peak and your trough. If I multiply the peak is 1. And if I multiply it by 1/2, I get a new value, 1/2. The trough or the dip is a better way of saying it, most people know dip more than trough. That's at -1, and if I multiply that by 1/2, I just get -1/2. It decreases how far up and down they go. But the zeros still stay the same. So that is y equals 1/2 sine x. And my green one is y equals sine x. And we're gonna do the same thing with cosine x. It's just. Well, now we still have our x values are still the angles. So. We're replacing x, when we do our graph, our angles are still gonna be along 0 to 2 pi. But now our output is really the x coordinate of the unit circle. Cause cosine is our x coordinate. So that's what we're gonna use. Instead of pulling the y value, we'll pull the x value. So when our radian, let me put a y equals 1 and -1 in there. When our radian value is 0. Our output is 1. From there. And when we're at pi over 2, our output is 0. And when we go to pi, we're looking at our x value, it's down to -1. We get to 3 pi over 2, we're back up to 0. And at 2 pi, we're back up to 1. This starts repeating. And again, you can find the period looking at the graph by picking any 2 points where it starts repeating. If you just have the graph and not the equation, you can find the period by seeing where the graph repeats. We've already looked at what putting a number in front of the graph does. The number in front of the graph changes the amplitude. Before we get to changing the period. I want to do another graph on here. Our period's gonna stay the same, but we're gonna shift the values. By saying x minus pi over 2. And if it helps making a little table, I'll make a little table like this. We got x, I've got y equals cosine of x minus pi over 2. And let's plug in our 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when I plug in 0, I really have 0 minus pi over 2. We're looking at cosine of negative pi over 2. So what's the x value at negative pi over 2? We're down here on the unit circle. The x value is 0. So that's my y value now. So I have 0, 0. When I plug in pi over 2, I have pi over 2 minus pi over 2, which is 0. Cosine of 0, we know from the unit circle is 1. Keep going with this. Pi minus pi over 2 is pi over 2. We're back at 0 again. If I stick in 3 pi over 2 and subtract pi over 2, I have just pi. And cosine of pi is -1. And that's happening at x equals 3 pi over 2. And finally, if we stick in 2 pi, we have 2 pi minus pi over 2 ends up being 3 pi over 2. And we can see the x value here is 0. And we know our period hasn't changed, so that's where it starts to repeat. I'm just going to connect the dots in a nice rolling wave. Oh, if I can keep this. What does my green graph look like? Looks like sine, doesn't it? Is it any different from sine? If we look at our green wave here, we had 0, 0, pi over 2, 1, pi over 2 and 1. We had pi and 0. We had 3 pi over 2 and -1. And we had 2 pi is 0. In fact, this is identical. It's not even close, it's identical. Y equals cosine of x minus pi over 2 equals sine of x. That's deep. That's pretty cool. It really just shifted. So. Since this is like shifting the graph a little bit. They call this value right here is called the phase shift.
This is this circle or all circles?
The unit circle has the radius of 1. When we don't have a radius of 1, it's like having the amplitude be different.
Okay, so it's.
Yeah, so like if we had a 2 out front, we're no longer on the unit circle, but we're on a circle with a radius 2. Yeah, but all the angles carry through and. That's a good observation. I'll point it out next one of the one we do in a second. Why don't you guys take a second and do y equals sine of x plus pi over 2? If it helps, I'll leave the unit circle in sight. So, a couple of are still working. We did another minute. So what value should I have for 0 radians? -1? Positive, which? Wait, what? Positive one, right?
Yeah.
I stick in 0, I have sine of pi over 2. Sine of pi over 2 is 1, Jordan threw me off. Oh wait, did I write down the wrong fucking thing? Or is Amy's for a specific thing? What about if I stick in pi over 2?
Zero.
I'm doing sine of pi. And I get 0. And what about pi? If I stick in pi, I have 3 pi over 2. And 3 of pi over 2, we're down at -1. And if I stick in 3 pi over 2, we have 4 pi over 2, which is 2 pi. Sine of 2 pi is 0. And if I stick in 2 pi or 4 pi over 2, we get 5 pi over 2. We're up at 1. And what graph is that? That's cosine. This wave-like motion is how light and sound travel. You study physics, you'll go into this. And like on light, color is based on, I believe, the frequency. Or how short or long the period is. Brightness, I believe, is amplitude. Whereas sound loudness is amplitude. And the frequency or how short the period is. Kind of affects like. You know, the radio station, when you turn the knob, if you still do that. Those are catching different wavelengths or different periods. So they can send out, like every state radio station has a different. Wavelength they send it out on, they send out the same music on a different period. Well, they could. You could have 2 different radio stations sending out the same song, but on a different period. And when it gets to your stereo, it takes it apart and puts it into the right speed, so it sounds like a song to you. That's how light and sound work. This is kind of actually very important to most of the things you appreciate in life. Entertainment is, a lot of our entertainment is video and audio. And it's all based on brilliant people doing shit with this. Let's keep going with it. Hopefully that puts a little appreciation for where this is going here. Now let's change the period. So let's do y, we'll go back to cosine for now, let's do 1/4 x. And I'm gonna graph cosine real quick. Without putting values on the x-axis. And we know cosine does this. This isn't changing. The wave isn't changing. I know these values for the traditional graph are pi over 2, pi, 3 pi over 2, and 2 pi. I can figure out what they wanted me to be if I just set 1/4 x equal to these. 1/4 x equals pi over 2. If I solve for x or multiply both sides by 4, you see that x equals 2 pi. So that actually has to be 2 pi right there. If I do the same here, 1/4 x equals pi. Again, we're multiplying by 4, we see that x has to equal 4 pi. And once you have a couple, you can see the pattern, these are going up by 2 pi each time. We should get 6 pi here and 8 pi here. And so if we call this value 1/4, if 1/4 we call it b. Our period went from 2 pi. To 8 pi. And how could we do that mathematically? 2 pi divided by 1/4 will give me 8 pi. And that's how we can see and why the period is 2 pi over b. That's a slower walkthrough of where it comes from. So how can we use that? Let's do y equals sine of 1/3 x. And take advantage of that property. We know what the sine wave looks like. Just need to fill in the x-axis. And just like up above, b was our multiplier on x inside. B is our multiplier here. Y equals sine bx. So b equals 1/3. And my period has got to be 2 pi divided by 1/3. You multiply by the reciprocal on bottom and top. And we see the period is 6 pi. So we're going from 0 to 6 pi, it should start repeating at 6 pi. If it helps, take that 6 pi and multiply it by 4/4. And I'll get 24 pi over 4. The halfway point was actually pretty easy to do with 6 pi already. Cutting 6 pi in half gives me 3 pi. But if I cut 24 pi in half. 24 pi in half would be 12 pi. So this is like 12 pi over 4. And then we can see 12 pi over 4 does equal 3 pi. We're gonna cut that numerator in half again. 12 pi cut in half should give me half the distance back to 0. Gives me 6 pi over 4. And 6 pi over 4 reduces to 3 pi over 2. And finally, we're going halfway between 12 and 24. One thing you can do, an easy way to do it is just add these two. 6 pi plus 12 pi is 18 pi. And 18 pi over 4 reduces to 9 pi over 2, right? Which sounds funny. 9 pi over 2 is 4.5 pi. I said 2 when I wrote 4. Now, I usually tell you to do 4 over 4. Because 4 over 4 will always work. Sometimes you gotta reduce. If the numerator, or if this number is even. An even multiple of pi, you can just multiply by 2 over 2 instead of 4. And you can get it just as easily. If I had done 6 pi times 2. I would get 12 pi over 2. And I could cut that in half and get 6 pi over 2. I can cut that in half and get 3 pi over 2. And I can add them and get 9 pi over 2, and then there was no reduction. You see, those 4 values are repeated over here after reducing. But choosing the 2 over 2 only works when the number is even. If you always do the 4 over 4 is you want a one trick pony that always works. 4 over 4 works. It'll break up that value into things you know you can divide 4 times. You guys ready for more? You guys ready to try one yourself? Let's give you y equals 2 cosine pi over 2x. And Davis asked a question earlier. This is like doing a circle of radius 2. So you don't have to just do unit circle. But unit circle is the one you know. But the amplitude is affecting the radius. It just gets, it becomes a wonky definition as soon as that amplitude is negative. And it's hard, I don't wanna say negative radius, because that doesn't make sense. But for a positive radius, it works just fine. Should the period be? Anyone else get 4? Let's see if George's right. She tripped me out earlier with throwing me in with a -1, so. Let's check it out. 2 pi, we're gonna divide it by b, which is that. Which is the same thing as multiplying by the reciprocal. And the pi's cancel and I get 4. So what can I do with that? We're just gonna throw those down as our. Two, 3, and 4. And we're doing cosine, so cosine starts high. And does this. I got my graph of cosine in. What's missing here? My amplitude. What should I put in my amplitude as? 2. So this is my amplitude. So this is 2 and this is -2. This is how the approach I meant to take, and I realized that for some reason I had 6.3 and 6.4 both in my head, so I rushed it. This is a much better approach. Slow it down. Let's have you do one more before we take a break. Y equals -3 sine of 2x. And if you notice, what we did from the beginning, from the steps is. Find the new period. Plot the basic graph. Adjusted by amplitude.
Um, Professor Jones, I was gonna add that I like the second option, option B, to find the period and the starting point.
Wait, what?
The second option to find, you have like the greater than or less than sign.
I don't have a greater than or less than sign anywhere on that. Oh, you mean by doing like, 0 is less than or equal to x, less than or equal to 2 pi?
Yes.
Well, that's kind of doing the same thing. Do you really need to divide 0 by b? That's not changing anything.
No, I just like using that method.
Okay. Yeah, if that helps you. If not, if it works better for someone else in here, use that. That actually is a good way to show where it's coming from. 0 is less than or equal to bx is less than or equal to 2 pi. And when you solve for x, you divide by b. That's actually an easier way of showing where the period comes from. I try to show by example, like what values it gotta be. What am I getting for my period here?
Right?
Pi, right? So this is where multiplying it by 4/4 actually really shines. 4 pi over 4. Just keep cutting the top in half, 2 pi over 4, pi over 4. And pi plus 2 pi is 3 pi, 3 pi. Now my base graph would do this, and I'm doing the base graph in pencil. This would be y equals sine of 2x. What does putting the -3 on do? It does the amplitude, but how does it change how my graph looks? It actually flips it upside down and makes it bigger. So when we throw in the -3, this will go up to 3 now. This will go down to -3. And this graph flips over and goes down to -3. This graph flips over and goes up to +3. And our zeros don't change. So our graph looks something like this. Okay. You've got that deer in headlights look. It's processing. So what we basically did is we took the -3 and multiplied it by these values, but -3 times 1 is -3, I gotta move my 1, instead of going up to 3, we gotta go down to -3. And actually doing the base graph in pencil is kind of handy, or if you're doing everything in pencil, just do it really lightly. Like just barely put it in. And I'll keep doing the base graph from here on. Because the graphs get a little more complicated. So I'll put it in very lightly. And let's take a 10-minute break. And if, let me call the video, if you want your test, come on up. They're sorted alphabetically by last name, so tell me your last name when you come up. Alright, so let's kick it up a notch. Let's look at adding some shit to it. Let's do. I don't know, y equals. We'll just keep the amplitude the same, sine of 3x plus pi. There's a couple ways to go about this. We can rewrite this with the 3 factored out on the inside. And have this be x plus pi over 3. This allows us to, this is our b, it affects our period. And this is a shift after we do the period. Another way we can do it is the way Keith was talking about, and just take this and set this between 0 and 2 pi. I'm gonna go with that, but then I'm gonna work this afterwards. So here, if I subtract pi from both sides, from all sides. I get this is negative pi is less than or equal to 3x, which is less than or equal to pi. And if I divide by 3. I get negative pi over 3 is less than x, which is less than pi over 3. So that's my period. That's one range where the period is going to be, the base graph will be. If we follow this approach, I take my 2 pi and divide it by b, 2 pi over 3. Now we can see this here. Pi over 3 minus negative pi over 3 does get us 2 pi over 3. So this is the same period. And then we'll take both routes forward. This one, I would multiply this by 4 over 4. It'll get me 8 pi over 12. Oh, let's do that. So 8 pi over 12. Which is 4 pi over 6. 4 pi over 6 might be easier to cut in half. Smaller numbers. That would give me 2 pi over 6 here. Pi over 6 here. And 3 pi over 6 here. Now my base graph is here. We're doing sine, so it's doing some shit like this. My base graph is looking like this. After adjusting for period. So that's just y equals sine of 3x. The phase shift is pi over 3. And if I get a denominator with 6, that's 2 pi over 6. And it says positive, which means it actually goes the other way. It shifts left. So I'm going to go left 2 pi over 6. Negative 2 pi over 6. And I'm going to take all my points and move them left that many increments. This will go over 2. This goes over 2. This goes over 2. And this point comes over here. That's actually our finished graph. We've done our shift. We've done everything there. We can show it repeating, but this is 3x plus 5. Notice that this is negative pi over 3 and pi over 3. So this gets us to the right region. So doing that approach takes us to the right region right away. But now breaking it into fours can be more challenging. In this case, I don't think it is. This case is fairly easy. If I multiply this by 2/2, I get 2 pi/6 and negative 2 pi/6. I got 0 in the middle. And I can cut those numbers in half kind of easy. And then you do your base graph off of that. So both approaches are just as useful. This one, I jump straight to 2 pi/6 and negative 2 pi/6. And that makes this pi/6 and negative pi/6. And I can throw my graph in now, remembering that sine starts at 0. And I should probably put in my amplitudes. Any questions? Let's take a look at another one using cosine. We're going to need this up longer. Up and goes up. Not head up. I'm gonna do one with cosine, we'll do both approaches. Let's do y equals cosine. 1/2 x plus pi/3. So one approach is doing the period is 2 pi/b, which is 2 pi/1/2, which is 4 pi. And I need to figure out what my shift would be, I need to factor out the 1/2. So y equals cosine of 1/2 x plus, and this is a little tricky, so I'm gonna show really what we're doing. By pulling out the 1/2, I'm only dividing that by 1/2. And so I'll do some calculations on the side to see what that is. Pi/3 divided by 1/2 is the same as multiplying by the reciprocal. And I get 2 pi/3. Alright, so. My period is 4 pi. And since I'm gonna be shifting by increments of pi over 3, I'm gonna put like little 3 increments in here between each of these. Now, each of these little mini lines is pi over 3 in distance kind of thing. This is gonna help me translate afterwards. I know I'm adding, so I'm gonna be moving left, so I left more room on the left to go left. And I don't know how much more left I'm gonna go, so I'll just do that. It doesn't look like I have any scaling on my amplitude, so the height stays the same. And I will pencil in the base graph. Oh, cosine is not that one, I just did sine. Cosine starts at 1 and it goes downward. So the penciled in value would be like cosine of 1/2 x. Got a question, Jordan? Okay. And now we're gonna shift by 2 pi over 3, which means go left 2 pi over 3. Since I broke pi, these increments into pi over 3 dots, I'm just taking my points and moving them left 2 pi over 3. Now I'll make my wave. And if I move this point left pi over 3, it would be here. So kind of like that. If I move that left 2 pi over 3, it would go down to there. So that's what it's gonna look like. Let's try doing that same thing the other way. Let's try doing it where we set this between the argument of our cosine. Put that between 0 and 2 pi and solve. I know I need to subtract pi over 3, so I'm gonna write this in terms of pi over 3 by just multiplying by 3 over 3 real quick. So 2 pi times 3 over 3 gets me 6 pi over 3. Now, when I subtract pi over 3, it's a little easier to do. I have 1/2 x is between negative pi over 3 and 5 pi over 3. And when I multiply by 2, I get negative 2 pi over 3 is less than or equal to x, which is less than or equal to 10 pi over 3. That tells me right away where my graph is gonna be centered at. So it looks like I'm doing increments of pi over 3, maybe I'll just make 2 of them to the left. And I'll make 10 of them to the right. And my amplitude is staying the same. And now I'll put in negative 2 pi over 3 and 10 pi over 3. So now it's figuring out where my points are at. If I do the 10 pi over 3 and subtract the negative 2 pi over 3, I get 12 pi over 3. And that's showing me my period is 4 pi. We can see that now, but now the 12 pi over 3 I can break up into fourths. So I would have 0 and 12 pi over 3. Halfway would be 6 pi over 3. 3 pi over 3. And 9 pi over 3. From the negative 2 pi. So add these to negative 2 pi over 3. I'm really shifting over 3 of these at a time. 3 pi over 3 minus 2 pi over 3 puts me at pi over 3 here. And 6 pi over 3 minus 2 pi over 3 puts me at 4 pi over 3. And 9 pi minus 2 pi is 7 pi. 5, 6, 7. 7 pi over 3. So that's what I'm doing. I'm taking my values and subtracting the 2 pi over 3 each time. And this makes it so you jump straight to the points and you don't have to shift the graph. We know cosine starts at pi. And we are using these values that we mark here as our points. It's a different method of doing the same thing, it just depends on which one you like doing. We're gonna add a little bit more to it by adding in a vertical shift to see how you guys like it. Any questions so far? Again, either of these approaches works, so whichever one you prefer. But you're gonna have to do something like this on the test, you're gonna be asked to graph these. And I'm expecting to see some work that corroborates your graph, because some of you have a graphing calculator, and if you just copy the graph without any supporting work. You're not getting shit for fucking points. You're not getting rewarded for having a graphing calculator, other than knowing your graph is right. That's all you got. Any questions? Couple of people are still right, I'm gonna wait a second. Okay, let's add some more to it. Let's do y equals 2 sine of 2x plus pi minus 4. Full package, everything's in it. Both of them work well finding the base period. Both approaches. So if we do the approach that I started with, I will factor out the 2. Ends up dividing that by 2, and we see that. So my period, this is my b. My period is 2 pi over b, which is 2 pi over 2, which is pi. I got more going on in this graph, so I'm gonna add a lot of vertical height to it. If I multiply that by 4/4, this is like 4 pi over 4. And it kind of makes finding these middle values a little bit easier. 2 pi over 4, pi over 4, 3 pi over 4. And I'll be shifting left pi over 2. And to make it so I get a common denominator, I'm shifting left 2 pi over 4. And I will pencil in my base graph. Let's do it at a height of 2. So my base graph before my shift is right here. Oops. So that's 2 sine 2x right there. So this is giving me my shift left. And the -4 is giving me my shift down. So I'm going to take each of these points and move them left 2 pi over 4 and down 4, which means I need a little more room on this graph. Down to -6. So left 2 pi over 4, down 4 is right about there. Shift this one left 2 pi over 4 and go down 2, we're right about there. So this is like A and B, and this is my new A and new B. And we're gonna follow that pattern, 2 pi over 4, go left, 2 pi over 4. Down. Once you have the first few points kind of in, as long as you know the pattern, you can follow the pattern. I need to be making a wave. So 0 up, 0, then down. Down to negative, down 2 more, and then back up 2 more. So that point's going there. And I got my wave. And it's gonna kind of keep on repeating there. Let's take a look at the other approach. Setting that between 0 and 2 pi. So we'll subtract pi from both sides. And divide both sides by 2. And we have negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. This is handy in that I can set my graph immediately to that region. And I just need to figure out what my midpoints are. It's kind of handy when it's evenly balanced like this, pi over 2 on each side, you just cut them in half. When it's oddly shifted, like our last problem was. Where we were going from negative 2 pi over 3 to 10 pi over 3. That's where cutting them in 4 parts is a little harder. But this part's relatively easy, just cut those in half. And we're doing sine, so my base wave has an amplitude of 2. And we're doing the 0, 1, 0, 0, negative 1, 0, modified by the amplitude. That's the base. And now all I've got to do is shift it down 4. Same way of drawing, or different ways of drawing the same graph. Which way seems easier to you guys? Do you guys like method A or method B? Who likes A? Who likes B? Let's see if you still like B after the next one.
I have a feeling there's.
I agree, for this one, B was a little bit easier, you shift right to it. It's a little easier to track just up and down motion, that's kind of, that's the better part of B. You're just going up and down at that point. It's when they're not evenly balanced on each side of the graph. Something like this. 3 cosine of 5x plus pi over 2. Let's just do plus 1. No, let's move it way up. Let's do plus 5. So I'll start by figuring out what that new period is. 2 pi divided by b, which is 5, is my period. And if I multiply that by 2 over 2, this is like 4 pi over 10. And I know I'm gonna be shifting up a lot. So I'm gonna give my vertical part, the top half, a lot more room. Four pi over 10. 2 pi over 10. Pi over 10. And 3 pi over 10. Now, what is my shift gonna look like? If I factor out the 5. That's the same thing, dividing by 5 here is the same thing as multiplying by 1/5. I get 5 times x plus pi over 10. So it looks like we're gonna be shifting left pi over 10 when we're done. And it might be easier to put that shift in right away. So let me pencil in the 3. So if I were doing cosine, it would start at high. And go to low and then back up. And then I'll shift it over pi over 10. So this penciled in graph is cosine of 5 times x plus pi over 10. With a 3 in it, got the 3 there. I mean, if I had done the original one, it would look like that. This is just 3 cosine of 5x. And now we're shifting it up 5, we want to add 5 to it. That would put me up to 8. So these values gotta go up 5 to the 8. And if I go up 5 from -3, I'm going up to 2. And this should be at 5. I don't think fuck. Yeah. And put my 0 there. I don't got this evenly spaced, do I? Left to right, there's not like, looks bad. Yeah, I had graph paper, this would be a little bit easier. But this is what you're gonna be doing on hand, because there's no, like, on the test, because we don't have graph paper on it. They won't print that shit out, so. As long as you got it labeled, I'm good. So that's adding our +5 to it. Other way, we're doing the 5x plus pi over 2 between 0 and 2 pi. What's up, Keith? Okay. So we'll subtract pi over 2. And 2 pi minus pi over 2 is 3 pi over 2. I'll multiply everything by 1/5 to clear the fraction. And we get negative pi over 10. Is less than or equal to x, which is less than or equal to 3 pi over 10. And to find the spacing, you gotta do subtraction. If you don't spot it right away, subtract the lower one from the upper one. So 3 pi over 10 minus pi over 10 is 4 pi over 10. And if I break this up into 4 parts, it means every step is pi over 10. By doing this, I find my steps, so from starting my first thing, I'll go pi over 10 each time. And put another point. So this would be pi over 10 here. And 2 pi over 10 there. You've got your base graph. And now shift up 5. That last step is the same for both of them the way I just did it. So here, I did the shift in 2 parts. I did my cosine. Cosine started like this. I shifted to pi over 10 left first, then did the +5. You can do that all at once, do the pi over 10 left, up 5 at the same time. Here we did jump straight to the right shift, left and right, and then we got to add the 5 afterwards. So we'll be up to 8. That one's there. And you're doing your cosine here. All right, that's all I got for you. Hopefully that may help make graphing sine and cosine a little bit easier. And we will do tangent, cotangent on Wednesday.
Thank you. Have a good day.
Thank you. You too.